Okay, hi Year 12. Today we're going to have a look at the reverse chain rule. So this falls into Chapter 4 in our integration topic, and it should fit into 4i is what we're going to have a look at. And this will finish off our first part of integration, and it's something that it's towards the end of the term, and you're probably getting tired and you finished your exams, but we still need to know how to do this. It's fairly straightforward, but it will incorporate differentiating, okay, as well as finding the primitive function. So let's have a go and see how you go. Okay, so we're going to work through the examples basically, and we'll see how we go with those. But we need to know how to differentiate first. So we're going to differentiate x to the power of 3 plus 2 or to the power of 4 with full setting out of the chain rule. So we're going to find d dx of x to the 3 plus 2 to the 4. Now, to remember how that happens, see if you can pause the video and see if you can differentiate it. But what we're going to do is get our power of 4 and bring it down the front. We've got x to the power of 3 plus 2. We're going to take one off that power, so it becomes a 3. And what we did was then we would multiply by the differentiated part inside our bracket. So we're going to multiply by 3x squared. So what we will end up with is the 4 will times by the 3 to get us 12 x squared, and our brackets are x to the power of 3 plus 2 or to the power of 3. Okay, so that is our first solution. That is the derivative of our function x cubed plus 2 to the power of 4. Now we're going to remember what it actually means to integrate and to differentiate. So these guys basically are the reverse of each other. So we'll go differentiation and integration. Oops, I'm not having a good day of spelling here, am I? Okay, one's forward, one's backwards. So what our question is then getting us to do, it's saying hence. So what does hence mean? Hence means, let's use the information from the question before, hence find the primitive of this function here. So our 12x squared times x cubed plus 2 to the power of 3 is the same as what we have got. So if we were to write this as an integral, 12x squared, x cubed plus 2 to the power of 3, if we integrate this, we're going to go back to what we had before, which is going to be x cubed plus 2 to the power of 4. Can we see what's happened there? So these are just the opposite of each other. When we differentiate this, we get this function. When we integrate this, we get this one. So they're vice versa. They're the opposite of each other. Now, look at part C. It's giving us a hence again. We've used our hence one. Now it says hence. Hence, find the primitive of x squared, x cubed plus 2 to the power of 3. Now, I need to have a little think about this. These guys are very similar. What is the difference between our first function that we've got given in part B and the function that we've got given in part C? The difference is this 12, isn't it? This is 12 times bigger. We have 12 times the size in part 2 than we have in part C. Now we knew that when we integrated our larger number with the 12 in there, we got this here. So if I was to take away the 12 here, and I divided by that, so to get rid of the 12, I'd have to divide by the 12, then I would divide by the 12 here. So if I was to divide by my 12 on the answer I got before, I would have my new answer. Okay? So the 12, the function with the 12 in front, gave me this function when I integrated it, or found the primitive. So to find the primitive of this one here, and I might just write that down in the long way. So we'll rub this out and we'll write it the long way. So now I'm going to integrate x squared, x cubed plus 2 to the power of 3 to dx. It is 1/12 smaller, so my solution is going to be 1/12 the size of what I got before. And that is basically looking at the reverse chain rule. We look at what happens when we differentiate something, and we can go back and forwards, and then we can see, well, this is what I would get if I
integrated this function, how can I get the new one? And that's how we're going to work our reverse chain rule. Okay, so let's have a look at the next example. We're looking at the reverse chain rule to find the integral of x times the square root of 1 minus x squared. There are a few ways to do this. Looking at different textbooks might look at it a little bit differently. I'm going to show you the way that I like to do this, and I'm going to have a look at what's happening underneath the square root sign, and I'm going to do a substitution. So I'm going to let u equal to 1 minus be equal to 1 minus x squared. And so if I was to find then u dash or du dx, I'm going to get minus 2x. So I like to do it this way. I think it's quite simple and straightforward, and we can do a substitution straight in for our solution then. So I want to find my integral. So I need to substitute in for x. I need to substitute in for the square root of 1 minus x squared. And I want to also substitute in for, or not substitute in for dx, but I want to think of dx as a term. So I'm going to put my u in first. So I'm going to pop in, and I've still got my x, but I'm going to pop in my square root of u. So this is to substitute in this part in here. Now my x, I want to substitute in x. Now I've got that du dx is equal to minus 2x. Now I'm going to do something that we've not done before. I'm going to get rid of that minus 2, and I'm going to be left with an x, because I want an x. So I'm going to divide by minus 2 on that side and minus 2 on that side. So what I'm going to get is that over here, minus a half du dx is equal to x. And that's what I'm going to substitute in here for my x. So I'm going to have, I might just pop it out the front, minus a half. I might put my du dx here at the end because it looks a bit neater. And I've got a dx still. So let's have a look at what I've done again. If you like, I'll pop that minus a half back in under the sign, if that's something you would prefer for now. Okay, so let's go through it again. I've found a substitution for 1 minus x squared, and I've called it u. I've differentiated my u to get du dx, and I'll neaten that back up here for us so we can see what we had. So I've got du dx is equal to minus 2x. And so what I want to do is I need to substitute in for my x as well. So I've got a minus 2x, but I want an x. So I'm going to divide both sides by minus 2, and I can do that. So I'm going to have minus a half du dx is equal to x. So my x gives me my minus a half du dx. I've got the square root of u, and I've still got the x on the end. So what happens is these guys can actually cancel out. Now I've got everything in terms of u. So that's going to be equal to, I like to put my fraction out the front, minus a half, this integral of u to the half du, which is, let's work out that. We're going to have, add 1 to the index, u to the 3 over 2, divide by 3 over 2, plus c. That will give us minus a half. When I divide by a fraction, I times by its reciprocal, u to the 3 over 2, plus c. This will cancel out. And what I'm going to end up with, whoops, just scroll down a little bit more there. What I'm going to end up with then is a minus 1/3 u to the 3 over 2 plus c. Now all I need to do now is substitute back in my u, and then I'm done. My u from the start, we remember, is 1 minus x squared. So I just need to pop that one back in, and I'm good. Go back down here. 1 minus x squared. So my solution is minus 1/3, 1 minus x squared, 3 over 2 plus c. So I'm back in the OneNote under integration now. There's a tab called exercise 4i, and I would like to have a look at a question in there, and I'd like you to have a go at this one as well. Just because I don't think we're ready for the reverse chain rule yet, we need to do a little bit more practice. So use the formula for the reverse chain rule to find the integral of x squared times x cubed plus 5 to the power of 3 dx. I'm going to do a straightforward substitution again. I'm going to let u equal x cubed plus 5. So du dx is going to be 3x squared. Now, we have an x squared in here. I have a 3x squared. So what I can do is divide by my 3 and get 1/3 du dx is equal to x squared. And now I have a substitution that's going to work. So I'm going to integrate. My x squared is going to be replaced by 1/3 du dx. I'm going to put the du dx at the end because I think that will look a little bit nicer. My x cubed plus 5 to the power of 3 is my u to the power of 3, and my dx can stay there. I've changed now to u's. So I still have this. I'm going to put the 1/3 out the front. You don't need to, but I like to do that. And now I'm going to integrate. So I've got 1/3 u to the power of 4 on 4. That's still in there, plus c. So I'm going to end up with u to the 4 on 12 plus c, because my 4 and my 3 multiply together. And so what I'll end up with is back into my u. I've got u to the 3 plus 5. I'm going to change my u to the, x to the 3 plus 5 to the power of 4 over 12 plus c. People are able to do these without the substitution, and if you can see that, that is fine. Personally, I like the substitution because there's little thought necessary. As long as you've got u, the rest of it will fall out nice and neatly. So that's my preferred method. You can do it another way. That is fine.